Yo, what's up everyone? I'm pretty excited about today's lesson. I think this is a really cool explanation. And before we do it, it's going to be really easy. I'm going to try to explain. So before we do it, and you're going to see that the things we do here today are actually really easy, like easier than yesterday. I'm going to run a side example to kind of explain the big thing we talked about yesterday, which was that if you have a log and you want to solve it, but this number raised to some power doesn't give you this, all you do is split that log. All you do is split that log into two logs with no base number. So we're trying to figure out what is the implied base number first of all, and why does this even work to begin with? Okay, so I'm honestly stoked because I've been working through this example, or like this concept. But before we do this, we're going to actually go backwards, and we're going to tackle a logarithmic equation, and we're going to go from here. Okay, so this equation, or this like little expression, says log base 4 of 256 divided by log base 4 of 16. And if you were being asked to simplify this, first notice that this is very similar to this. We have the same base number. There's no base number here, but that's going to mean the same thing as the same base number. But we're going to try to solve this. And whenever you see a fraction, think of both sides as separate. And if you can do something to one side, or the top of the fraction, you want to do that first. So all we're going to do to solve this the first way is just do them individually and then divide. This looks really intimidating, but we can just simplify this, right? Log base 4 of 256. I'm always trying to tell you, if you can turn an expression into a number, do that first. So 4 to the 4th power gives us 256. And it's okay if you didn't know that, the power chart's still useful. But then here it's log base 4 of 16. 4 to what power gives me 16, and that's 2. So this is just the same thing as 4 divided by 2, because this equals 4 and this equals 2. And then if you were to solve it, you would get 2. Now this is where it starts to get interesting, okay? So we got a whole number. This worked out perfectly. Every component of this worked. And if we're going to think about the rule we learned yesterday, if there wasn't a base number here, so let's pretend there wasn't a base number here, and we saw this, we know that this is just how you put it in the calculator if you wanted to solve this equation. So yesterday, if I asked you to solve this, you would take the top number, put it on the top, the base number, put it on the bottom, and this is how you would solve it, right? So hopefully everyone's with me on this, that this and this are kind of the same thing if we take away the base numbers. And if you think about this, 16 raised to what power gives me 256? You could just do 16 times 16 on your calculator and figure out that it's 2. Okay, so they both equal the same thing, and that's really important. And that worked when we had 4 as the base number, okay? So we had a base number in this question, and that's why this question worked out perfectly. And we figured out that with the base number 4, this still holds true. Okay, so if the base numbers are the same, those numbers can kind of be filled out with a log. My throat, I don't know, I got allergies and it's been kind of a bummer. My throat, I definitely feel like I'm talking weird, but I think it's probably fine. I'm probably overreacting. So what we're going to do here now is change the base number, and I think that that's really cool. So we know that this rule worked with 4 as a base number because that's kind of easy to solve. But what if they both had 5 as a base number? And this is a question that we couldn't have tackled till yesterday, but now we could actually just solve this whole thing. And the way we do it is by doing it separately. So figure this out by putting log 256 divided by log 5 in the calculator, and then you could do log 16 divided by log 5 on the bottom. Okay, and I said that fast, but it's just essential we know how to do this, and that was like the only skill from yesterday. So if you do that, I'm gonna solve what it is right now. And it's, I'm not gonna actually. And if you're not getting those numbers, refer to yesterday's video because that's really important. And maybe you can already see what's going to be cool about this. But we solved both of these individually. So if I wanted to solve this equation, let's just do this divided by this. And if you do that, you're gonna get 1.997, aka 2. You know what I mean? Just 2. So what we're, and hopefully this isn't too confusing. I think it's more interesting than confusing, and this is now the hardest part of it. But what is really interesting about this and really fundamental about this is even though we changed the base number, we still got the answer 2. Okay? When it was 4 and 4, it made sense logically. But if we put a number like 5, this is really random. 5 to the 3.44 power gives me 256. And that's something that's really weird. And then 5 to the 1.722 gave me 16. And then if we divide them, we get 2. Okay? So it doesn't matter what this base number is. It's going to give the same answer. So once that logic flows, like once you kind of understand that, the way that mathematicians decided to do this was, let's just start writing logs with a single number and then have an implied base number. If the base number is actually not that important, if we can always convert something like this into 2 equations with the same base, regardless what that base is, then they just needed to choose a random base. And it wasn't random. We're going to talk about why this is important. But if you ever see, we're going to do number 3 now. I want more space though. So now we're back to a question from the packet. But if you see log 10,000 with no base number, that base implied number is 10. Okay? So 10 was the number that was chosen to be the base number for all logs without a base number. And that's because they just needed to pick a number. And then 10 actually is really beautiful with logs, and we're going to see when we graph why 10 is the perfect base number to be implied. But just think like with 10,000, that's going to be 10 to the 4th power. So this would be 4. And now let's do it on a calculator so that we get it. If we ever see log base 1,000, if we ever see log 1,000, the answer is 3 because there's no base number, but that implied base number is 10. And you can solve anything. Log 89 is going to be like a little less than 2 because log 100 is 2. So that is the implied number. And if you wanted to do it on your calculator, it works the same way. Where 1,000 log 10 is 3. So that's why it says log base 10 on the bottom. The 10 is not necessary because the implied base number is 10. Okay. So that's more kind of explaining yesterday's stuff than even explaining today's stuff. But I think that that's pretty cool. And that's the proof. And if you listen to all that, I really appreciate you. So for the actual problems we're going to solve, this actually becomes very easy. If we see log base 1,000 and we wanted to solve that, all we have to do is put log in 1,000. So for like number 4, remember that if there was a base number, you have to convert this to 2 logs without a base number. But if we don't have a base, this is so easy to solve. You don't even need to do 2 of these and divide. You just put it in. So log 49 is 1.69. So this is actually easier than yesterday. But what's really important is understand what's happening if there's no base. Because this is one of those things that will get kind of tricky. And if you don't know why there's no base number anymore, you're kind of going to be left out. So there's no base number because the implied base number is 10. And that works out for all the math we need with a base number because we can convert it to 2 logs without a base number. And then for number 5, I think this is kind of cool. This is the only other kind of question. And then I'm actually going to do a challenge question because I think this video is pretty short, light on kind of hard question, so I'll do a challenge. But if you see 10 to the x equals 70, we're going to be able to solve this with one calculator thing, but we're going to talk about how we can solve that. Remember that if we want to convert this to a log, I've done this too many times. This is the base number, this is the top number. And now because it was log base 10 of 70, there's no reason to split it up. Because the implied base number is 10, okay? So if you see 10 to some power equals that number, that's just hidden log with no base number. So all you would have to do is log base 70, 1.845. And then what's kind of cool about that, the reason that works is log of 10 is 1. And what's kind of cool about that is log of 10 is just 1, so that's how this all works. Because think 10 to the first power gives you 10. So log base 10 is 1. So that's why, because there's 10 as a base number, we don't have to do the second step. Because this is 1, it's just log base 70. So very quickly, if we were to do number 6, all you would have to do if you see this, 10 to the x equals 145, is log 145. Okay, so really easy, but really try to make sure you get it. Alrighty. Woo! So now I'm going to tackle a challenge question. Chewing gum, sorry. I'm going to spit it out. Okay, so we're going to tackle 23 and 24, and I appreciate everyone who's staying with me, because all this stuff I think is really worth it when you're trying to get to the next level. So like all my freshmen, sophomores, you want to take pre-cal, you want to take calculus, so this is kind of important. So the problem with this isn't 10 as the base number, and that's not that huge problem because we still could kind of do this the calculator method with this as the base number. It's not a big deal. But if we wanted to turn this expression into just a log, we're going to talk about what we would do. And again, the problem is this is not 10. So let's just forget about the x right now. And if we have the number 100, think, how can I turn the number 100 into 10 as a base number? And what you need to think is just 10 squared is 100. Okay? So if you don't have the right base number, you usually can find that base number, at least for the questions I give you, by raising some number a certain number of times. And what I mean by that is we have 10 squared is the same thing as 100. Okay? Wait. And what I mean by that is 10 squared is 100. And what's happening to 100 in the equation? 100 is being raised to the x power. So 10 squared is being raised to the x power, and then the rule we learned a while ago is an exponent of an exponent, you can multiply them together. So if we wanted to turn this into a log with 10 as the base, we've succeeded. We don't have x on the top, we have 2x on the top. Okay? And where we can go with that is, now let's turn it into logarithmic form. It's going to be log base 10 of 10,000 equals 2x. And if we wanted to solve x here, let's just solve this. 10 to the 4th power gives me 2x. So x is going to equal 2. Okay? So that's how you could solve this without a base number. Log 10,000 equals 2x because the implied base number is 10, and you could approach any of these the same way. So this one doesn't work out as pretty, but once we turn it into 10 to the 2x equals 1501, since 10 is the base number, it's just log 1501 equals 2x, and then I can just solve this, put this in the calculator. So that's how you could really storm through these. I guess there's only 2 other ones to do, but one of them is a little trickier. So 3.176 equals 2x. Just divide that number by 2. We get 1.588. Okay, so again, those are just extra credit questions, but I think that they're pretty cool. And this week continues to be decently easy, I think, but tricky and a lot of logic. So, good work. Woo!